Hi everyone, I'm Mr. Fullerton, and today I'd like to talk to you about Newton's third law of motion, oftentimes known as the law of action-reaction. We're going to explain the meaning of Newton's third law of motion. We're going to try and recognize and identify force pairs, and finally use Newton's third law to solve a set of dynamics problems. So to begin with, Newton's third law of motion states that all forces come in pairs. If object 1 exerts a force upon object 2, then object 2 must exert a force back on object 1. And the force that it exerts back is exactly equal in magnitude or size, but in the opposite direction. And you can see this all the time. For example, if you were to go punch a wall with a force of 100 newtons, the wall is going to exert a force of 100 newtons back on your hand, which is probably why you're going to hurt your hand. Or try this example. Take your hand and push it on the corner of your desk for a minute. As you push pretty hard, the desk pushes back on your hand. Now look, you can even see the indentation in your hand from where the desk was pushing back on you. Mathematically, we can write this as the force of object 1 on object 2 is equal in size but opposite in direction to the force of object 2 on object 1. For example, cat run forward. Well, to move forward, what a cat really does is it pushes backwards on the ground, and the ground pushes the cat forward. Newton's third law. If you want to swim forward, which way do you push on the water? If I want to swim, I push backward on the water, and the water pushes me forward. Newton's third law in action again. Or how do you jump in the air? If you want to jump up, which way do you push with your legs? You push down. As you push down, the reaction of the ground pushing on you propels you up into the air. Now, as you can see, all of these forces come in pairs, and these are known as action-reaction pairs. Let's talk about some of the action-reaction pairs. For example, a girl kicking a soccer ball. If the girl's foot kicks the soccer ball with some force, she applies a force to the ball applies an equal in magnitude but opposite in direction force on the girl's foot. So the action-reaction pairs would be the force of the foot on the ball and the ball back on the foot. A rocket ship in space maneuvering would be another example. If it uses a rocket engine, a rocket engine, as the gases expand, they get hot, they are forced outwards out of the rocket. The particles that are expelled outwards push the rocket forward, the action-reaction pairs. Even yourself, right now as you're sitting wherever you happen to be sitting, gravity is pulling on you. That's the force of the Earth's gravity pulling you down. But at the same token, you are pulling the Earth up toward you with the exact same force. Action-reaction pairs. So let's take a couple sample problems. The Earth's mass is about 81 times the mass of the Moon. So if the Earth exerts a gravitational force of magnitude F on the Moon, the magnitude of the gravitational force of the Moon on the Earth is, well, this is a really straightforward Newton's third law problem. If the Earth exerts a force on the Moon of F, the Moon must exert a force back on Earth of F, just in the opposite direction. 1. Or how about this one? A 400 Newton girl standing on a dock exerts a force of 100 newtons on a 10,000 Newton sailboat as she pushes it away from the dock. How much force does the sailboat exert on the girl? This is more a problem with understanding what you're being told as opposed to a physics problem. A 400 Newton girl, well, that's telling you the weight of the girl, not the force she's pushing the sailboat with. A 10,000 Newton sailboat is telling you the weight of the sailboat. Again, not the force. The girl's pushing with the force of 100 newtons on the sailboat, so the sailboat must push back on her with the force of 100 newtons, just in the opposite direction. Let's take a look at one more. We have a carpenter hitting a nail with a hammer. Compared to the magnitude of the force the hammer exerts on the nail, the magnitude of the force the nail exerts on the hammer during contact is, well, Newton's third law says right away these must be the same. All right, let's see if you can't take it a little bit further. See how many action-reaction pairs you can identify in each of the following scenarios. This will be good practice. Number 1, a car speeding up as it travels down the highway. How many action-reaction pairs can you identify? Number 2, just a coffee mug sitting on a table. How many action-reaction pairs can you identify here? And number 3, let's think of a frog sitting on a lily pad which is floating on a pond. How many action-reaction pairs can you find in that problem? Good luck, and if you have any questions, need more help, check out aplusphysics.com. Thanks and have a terrific day.